Hello everyone and welcome to WEkEO for Climate Change workshop. My name is Daria, I'm from Novelties, and today we will look at the usage of WEkEO data in QGIS exercise, which is dedicated to impacts of climate change on freshwater resources with Sentinel-2 imagery. For this tutorial, we will first get acquainted with the context of this study case. Then we'll have a brief look at the data from WEkEO platform we will use. And then, of course, we will focus on QGIS exercise itself. So let's start with the context. And as I said before, we will study impacts of climate change on freshwater resources using Sentinel-2 imagery. And as a study case, specifically, we will look at Doñana National Park, Doñana Wetlands, which is located in southern Spain. And well, southern Spain is one of the regions in Europe which is most exposed to the effects of climate change, particularly in terms of water scarcity. There is a river in Spain, the Guadalquivir River Basin, which is one of the country's main hydrological system. And this river basin plays a crucial role in supporting agriculture, ecosystem, and human settlements. So this Doñana Wetlands, Doñana National Park, it lies within this basin. It is a UNESCO World Heritage Site and one of Europe's most important biodiversity reserves. However, over recent decades, these wetlands and surrounding water bodies have come under severe pressure due to prolonged droughts, changing precipitation patterns, rising temperatures, and increasing water extraction for irrigation, agriculture, and urban use. So on this slide, particularly you can see on this image above, on this graph, you see the values of piezometer located next to the Zahillo pond in this park. And the red line marks the bottom of the pond. Here you can see the dates from 1994 to 2022. And you can see that the depth of this lake is fluctuating, of course, and then you can see that starting from 2015, 2014, we see that it's getting drastically lower and lower, and even reaching more and more the bottom of this lake. And on below there are two photos of this Zahillo pond. This one is in June 2011. We can clearly see there's water. And well, in October 2022, the lowest one, we see that there is no water whatsoever. And well, in this tutorial, we'll focus on detecting and analyzing changes in surface water, and we'll look at two dates. We'll look at July 2018 and July 2022. These two dates, we will use imagery from Sentinel-2. And by comparing the spatial extent of visible water bodies across these two periods, we aim to see the potential impact of climate change and human activity on these lakes, on these wetlands, on freshwater availability. Now let's look at the data from WEkEO platform that we used for this study. And here I'm not gonna go in details how to use WEkEO platform, how to download data. This information is provided in user guides on the WEkEO website itself, and as well there's also, for this tutorial, there is also a PDF file which will be provided to you, in which we also have this step-by-step procedure of everything I say here, but maybe with some more details specifically for downloading data from WEkEO. Here I'm going to just briefly show you what type of data we use, and as I said, we focus mainly on Sentinel-2 imagery, and we'll use two images from July 2018 and July 2022 in the middle of July. And these images, they are obtained from this product, Sentinel-2 and the WEI product. Here you can see the information about it. So we download only water index. So basically the resulted image will look like this, for example. So it will have only those bands included. Third, band 3, band 8, which we are particularly interested in for the water index. and as well true color and some other bands. It is important to note that we downloaded not 2 images, but technically 4. So we downloaded these 4 images, which are actually tiles. So we have 2 tiles for each date. So 2 tiles per period, so per July 2018, and 2 tiles for July 2022, because the zone we are looking at is not covered by one tile entirely, and only the 2 tiles are needed. So here you can see this 2018 tile SQA and a tile SQB, and the same for 2022. And the second product we are using from WEkEO platform is EO Hydro River Network. Here you can see the information about it. Well, it's a data set which provides a photo-interpreted river network consisted of surface interpretation of water bodies, lakes and wide rivers, and a drainage model also. So this is basically, for us, we're going to use this model as a base layer, as a comparison layer, as so like a model of these fresh water resources in the area. And now, without further ado, let's get started with the exercise itself. So if it's your first time working in QGIS, most likely you will have this as you open it. Well, it's already a new project which we opened. And for us to start it, we will do some adjustments. Well, first we will have a processing toolbox on a window on our right. For here you go to processing and toolbox, you click on it, or you also can click on this little gear icon like this. Great, and now we will also add a background layer for our project, so to have a representation of so to have the map for our products for future. For this we go to Layer tab, we go to Add Layer, Add XYZ Layer, and here usually also when it's your first time with QGIS, you won't have anything here. So you would click on New, and you would put a name, you would put an URL of the layer, and you would click on OK, and then you will click on Add and Close. But for us, we already have some as I use QGIS regularly, I already have some layers, and I usually use Google Satellite Hybrid. And if you can see, if you want to look at the details of it, there's an URL and all the name. And these links to these layers you can all find in the PDF file provided for you along this tutorial. So we added it, we click on Close, and now we have basically exactly the same view like we have in Google Maps normally. So we will zoom into our region of interest. So the river basin, it goes here. You can even, like, if we zoom, you see this river. It goes from CV and goes into the mountains. We will zoom in here and see later with our products. So we will start with satellite imagery first, and images were represented as raster tiles, and as I said before, we will use bands that are from Sentinel-2 and the WEI product. And in this product we have 2 bands, as I already said. It's a green and a near infrared bands, so band 3 and band 8, and we will load them, and then we will obtain our water index using some specific function of QGIS. So let's start adding our layers. We go to Layer tab, we click on Add Layer, and we choose Add Raster Layer. Here you can click on these 3 dots, and you can navigate to the folder with the data, which is also provided to you, but you also can, of course, go to the WEkEO platform and download it yourself to test it. Or what you also can do, I will show you. Let's first focus on that. And here we have our SQA tile, our first tile for 2018, and I need third and eighth. I can hold a control and choose them both. I open them, I add, they are added here on the layers tab. I close, and I see a new tile added here. You can also zoom on it by right clicking on it and click zoom to layer. Here this is our band 8, and if we untick a box we see in our band 3. You can repeat the same procedure to add our tiles, but you also can add the layers to QGIS project by go to your folder, and we already added SQA, right? Let's go to SQB for 2018. We go to the folder where we have the tiles, and we choose again the 3B8, and I select them and I drag and drop them. And they're also going to be added just like that. We unzoom a bit to see that now all our area and our area of interest is exactly this area. You can see here. Here you already see some water with some dark parts. There's a water, you see the river basin. And like this, the layers are also added. For example, now that's the 2 tiles for band 8, and that's the 2 tiles for band 3. Let's arrange our layers in a more appropriate way. We will create groups, so to have a more clean representation of our layers. Right click here, add group, and we will put 2018 and add group 2022. We will choose by holding shift our bands. We will drag them and drop them in 2018 like this. So like this, we have a little group, subgroup with only 2018 tiles, and here it's going to be 2022, so it's going to be easier for us to navigate in it. And now we will repeat the same procedure of adding raster tiles to our project, but now for 2022. So I'm finished with that, and here we have 4 tiles for 2022, 2 different tiles, SQB and SQA, for 2 bands, so 4 overall. Now, as you can see, we have a lot of tiles, a lot of images, and it might be not very convenient to work with them when they are separated. So let's merge the tiles. So basically, let's merge 2 tiles for each band, so for band 8 and band 3, for 2 dates. So instead of 8 images we have now, we will have only 4. So image for B3 and B8 for each date at 2018 and 2022. For that, we go to processing toolbox. In a search bar, we put merge, and we see merge in a raster miscellaneous in a GDAL library section. Double click on it. Here, in a pop-up window, you can choose the input layers. Let's choose the first one. So it's SQA tile for 2018 BO3, and we need the same date, the same band, but SQB. So SQB, okay, we have them here. We have 2018 BO3. Great. Okay, and here at the parameters you can save it to a file, and when you save to a file you choose choose a directory, or you can actually keep it like this without putting any name, and it will be saved in a to temporary file, to temporary memory, which means that it will be depicted in your project right now, right here, and but as soon as you close this project, well, as you close your QGIS project, even saving it in advance, when you reopen it, you will see the layer being provided in a layer tab, but it won't be depicted on the map, and you will see also a little icon that says that basically the layer exists, but the layer, like, the records of this layer may exist, but the layer itself is not, because you didn't save them to a file. So we're gonna save it to a file, and I prepared a folder for that. So by default it's a TIFF file format, and I prepared the name. It's going to be band 3 2018 merged. So we click on run, and it can take some time. So now it's finished, and we can go and check our layer. Here you can see that it's been created here, and if we untick all the boxes, we see it here. And let's see how it looks, and let's compare it to the initial images. So here we see that now it's basically the same image, just two merged tiles together. And you also see that the color bar has changed, the values in it has changed, the scale, because while two bands were separately, two tiles were having different scale, and of course when it was merged it was rescaled accordingly. You can repeat the same procedure going to the same window. You can just click change parameters here before closing it. If you already closed, you just go and click on here on the merge in processing toolbox again. And now instead you will use, instead of choosing these two bands, we are choosing for band 8. And we will save it as band 8. And we run it, and it will produce us the same result. And after it's finished, we're going to repeat the same for 2022. And well, I'm not going to include this in this video because it's the same procedure and you can repeat it yourself. When it's done, we can look at our result images. So we have band 3 for 2022, we have band 8 for 2022 as well, and then band 8 for 2018 and band 3. As you can see, our tiles, our new images, they cover a much bigger zone that we're interested in, because we're interested more specifically in this river basin, and the wetlands that are those in this area. So and the raster images, satellite images, they're usually quite heavy, quite bulky due to high resolution. They have a lot of pixels in it. So what we want to do is we want to limit our study area in order to just have a quicker processing further into the exercises. So let's clip our layers. For that, we can use our processing toolbox as well, or we can go to the tabs here, one of the tab here, and we need a raster tab. Before we will clip our layers, what we want to do is we want to change our coordinate reference system. We see here in the lower right corner that our coordinate system is EPSG 3857. We click on it, and we will set the usual one, which is EPSG 4326. We will click on apply, click on OK. Now we see it's changed, and we see that our layers up there. Now let's move on to clipping. So for that we go to raster tab, we go to extraction, clip raster by extent. Here we choose our one of our input layers, so we'll do it for band 3 2022, and then we will do it for the rest of for our images. And for the clipping extent, we already prepared it for you. You just need to basically repeat it. It's this one with noting with adding the coordinate reference system. And then we go to save to file, and we choose, it was B3 2022, and we rename it not to merged but to clipped. As it's finished, we can have a look at it. Here you can see, let's untick this box. Here you can see our original big image, right? And then you can see the overlaid clipped version. We can repeat the same procedure for the rest of the tile, for the rest of the images, by just changing parameters. Then they are all clipped. We can close this window, and now we see our clipped clipped images for both dates and both bands. So now, as the bands we need are all pre-processed, we can calculate the water index itself. And for that, we'll use a raster calculator. So we go back to our processing toolbox. We will search for calculator, and here it's a raster calculator. And in the pop-up window, we see expression window here, in which we will copy-paste the following expression. Let me just put it. So it's basically band 3 minus band 8, and this divided by the sum of the same bands. And we also add a condition that it should be more than 0, because we know that the positive values we will represent explicitly the water, and other values we represent, well, the other types of surfaces. So this expression is also provided in a PDF file, but you also, of course, can set it up yourself by using the operators given here and the layers given here. So also we need to add a reference layer. We will just add one of our clipped layers, for example this one, first one, and we will save our result to a file. Well, it's up, and it was 2018, right? Yes. Okay, so the water index for 2018, and while we run, and then it's finished, we will repeat it for 2022 by basically just changing our clipped layers to clipped layers for 2022. So let's zoom into our wetlands, and here we can see in white, as I said, white are water pixels and black are all other surfaces that were not detected as water. And this is for 2022. We can see this. We can see the river basin. We can see some water reservoirs here. And if we untick it to see 2018, we see that overall on this layer we see more white pixels present, like scattered all around. We also see more pixels belonging to the rivers itself, and well, some small rivers adjoined to it. And of course the main point is that the wetlands that are actually here, we can see that in 2018 there were much more water present, with more reservoirs and more water bodies here than it was in 2022, where it's clearly almost fully black. So now, to have a clearer representation of change in water level, we will do some more processing of this data over raster data and do some calculations. So first, as you can see here with this little icon, our water index layers were also raster layers, so that's our, like, these representations were made of pixels. And what we want to do, we want to turn it in a vector layer to have basically made of geometries, made of polygons. For that we will use polygonize function. We go to raster tab here, we go to conversion, polygonize, raster to vector. We will choose our layer, well, we are 2022, and the name of field to create, well, we'll just put our index up, and we will save it to file as vector one. Now, by default, the type is a shapefile. We will run it, and we will repeat the same for 2018. When they both are done, we can go look at them. So that's basically how a vectorized raster layer looks like, not very well representative. So for better understanding what's happening on this layer, we will filter it. So we choose our layer, right click on it, go to filter option, and here we'll choose the only field it has, and we will choose it equal to 1, as we said, to match water. Let's click OK. Okay, so now only the water fields are chosen. and we repeat for 2018 as well. And here it is. So if we zoom a bit more to wetlands, we see there the pink polygons that are representing 2018. They are overlapping with orange ones that are representing 2022, and we see that many zones, water areas in 2018 are present, and they ceased to exist in 2022. Before we move to the next steps, we would need to first fix our geometries, because, well, resulted layers, they might have some inconsistencies that are not visible to us, really, but they can be present there for the program, and they can obstruct our calculations. So let's clean the geometries by searching for fixed geometries function is here, fixed geometries, and well, we choose the first layer, and we'll save it as, well, as save to file. We will add F to save that it's fixed, and we run. We change parameters for 2022, and as I said before, we won't see a difference between those layers, but now they are ready to be used for further calculations. And one of these further calculations we want to do is to calculate area difference. So basically to evaluate numerically the difference in water level between the two dates, 2022 and 2018, sorry. And for that, we will use a tool which is called symmetrical difference. You can also try to search in the processing toolbox, but it's also accessible through vector, because now we will work with vector layers. Vector, geoprocessing tools, symmetrical difference here. So the input layer can be 2018, yes, and the overlay layer is 2022. And we save it as difference 2018 minus 2022. We run. And when the procedure is finished, we see a new layer, vector layer, difference 2018-2022. Let's untick all the others, and that's basically the difference between these two layers, yes. And these are water areas that existed in July 2018 but dried out by July 2022. And now what we actually want to do is to estimate how big this area is, and for that we will perform area calculation. So for that, we right click on our new layer, we go to open attribute table, and here we see two columns that do not tell us much. So we first toggle editing mode by clicking on this pencil icon, and then we choose open field calculator option. So here in the new window, we will create a new field, and we will call it area. The output field type is decimal number, and we'll put precision 6, because we know that some polygons are very small. And here we will search for area, and we will use the following expression, which is basically this one. If you don't have this formula, this expression yet added, it's normal, because, well, I use it quite often. You just type it yourself or copy paste it from the file we provide you, and then you will have it there. And here you can see a little preview which basically tells you for first feature it will be this amount of this area, which is of course area in square kilometers. For example, for second feature, it will be this, third, and so on. And then we click on OK. And as a result, you will see a new column appeared here. It's called area, with the areas of each polygon. And if you click on area here, it will be reorganized. It will be sorted out from smallest to biggest, or from biggest to the smallest, like here. So the biggest one area is actually 8 square kilometers. But we are not really interested in those small polygons separately. We are more interested in the sum area of those polygons. And for that we can do the following. First, let's leave the editing mode, and we go to View tab here. We go to Panels, and we need to choose Statistics panel here. We tick a box, and we have a new little window, or sometimes it's a panel like this, yeah, which tells you which can tell you statistics of different layers. So we will choose our difference layer, and here and here you select a field you're interested in. We are interested in area. And here you can see exactly that there are many statistics provided. And the first is a count, so how many features there are. There are 27, almost 27,000 features. And the second one is the one that we're mostly interested in. This is a sum, which gives us 65.4 approximately square kilometers. And you also can see some other ones like mean and median and so on. So this comparison we just made between the two dates, it reveals a loss of approximately, as we said, 65 square kilometers of water surface in the wetlands of this national park and in the river basin. And this is actually a substantial reduction, because it's equivalent to about 9,000 football fields. That's quite a lot, right? And that's exactly highlighting the growing pressure on freshwater systems in southern Spain, in this region in particular. And yeah, we saw that it's been just 4 years between the two dates, 2018, 2022. And of course, this loss we just detected, it suggests severe impacts from prolonged droughts, from reduced rainfall, and of course increasing water demand overall. So on that note, we kind of finished the first sub exercise of this tutorial, and we'll move to the next one. And in this next one, we will focus mostly on the second product of a WEkEO platform, which we discussed before, and this is river network and water bodies from EU Hydro River and Lake Network model. And we will compare this new product with water index we already obtained just now. And as I said before, this river network and water bodies layer data from WEkEO platform, we will use it as a reference layer representing the expected distribution of surface water in Europe overall, but we also look at specifically look at this region. And by overlaying this reference, I will say reference layer, with the water maps we just derived, we can access how actual water presence from Sentinel to images, how it actually compares to this baseline from the model. So let's add our second product. We go to our data folder, and here you can see in another folder, EU Hydro Guadalquivir river basin. We click on it, and we have this GeoPackage file. So we just drag and drop it to our QGIS project, and it will give us this window with basically all the layers available in this product. And there are many, really many of them, but we don't need all of them, we need only specific ones. we will add inland water. We'll hold Ctrl and choose Transit P, and we will choose RiverNet P. Now we can click on OK, and here we are. So now we have 3 new layers, also vector layers. So in pink we have our inland water. In red we have a river net out of smaller rivers, and in yellow we have a transit, which means basically the water basins that are river basins that are directly influenced by the tides, because we see that here they are specifically they are fed by the ocean. So as I said before, we want to compare this base layer with our water index obtained with our obtained water index masks. But first, let's a bit adjust these new layers for our usage. So first, we will close the statistics panel. We go to processing toolbox and we will search for merge again, but now we won't go for merge for raster layers as we did before. We will look for merge vector layers because now it's a vector, it's a polygons. And click on it, we go to input layers and we choose the three EOHydro ones. Okay, and we'll save it to a file and call it EOHydro. So we will run it, and when it's finished, we have a new layer, which basically the three different layers, three previous layers all together. But if we zoom out, we actually see that our product, we downloaded for the whole river basin, right? So it goes all up here. And we are not really interested in that much of information. So what we want to do is we want to clip our layer according to the area of interest, as we already did. But now it's gonna be a vector layer that's clipped and not raster layer. For that, in processing toolbox, we also search for clip, and we in a vector overlay we choose extract clip by extent. We choose our EOHydro input layer and extend. We will click and we will calculate it from a layer, and we calculate it from vector layer, and we calculate it from example water index in 2018. And we will save it to file as EOHydro area shapefile. And as a result, we see that this layer is now trimmed to the zone of interest. The new layer in green comparing to the previous layer, not trimmed one, in brown. And if we will overlay this new obtained layer with our previous ones for July 2018 and 2022, we will get the following picture. For that, we will drag and drop our layers, water index layers on top of it. For example, this is 2022, and we see the correlation between 2022 and the base layer, and the same for 2020 and the same for 2018. So from both comparisons, we can draw the same conclusion, that there were less water present in July 2022 than in July 2018, and there is also a noticeable difference between the two Sentinel images and the EOHydro dataset. And of course, this difference it can be attributed to several factors, and one of those factors is likely is difference in acquisition dates and update frequency between the datasets. We know that Sentinel images, they represent only specific moments in time. These images, for example, were taken in mid-July of each year. The EOHydro model reflects generalized, possibly also older representation of hydrography in the region, and also in addition, some water bodies in Sentinel imagery might not be clearly detected due to water color, turbidity of water, vegetation cover also, and all that can affect the reflectance and make water harder to be to distinguish among other surfaces. And also, as you can see from here, for example, the model dataset, on the other hand, also marks certain zones as being impacted by tidal variations, which also can explain further differences in water extent or shoreline boundaries between the two sources. And that was it for the second exercise of this tutorial, in which we looked at another product from WEkEO platform. And yeah, in this tutorial we looked at basically two products. One is vector one, and one is raster format. Raster one is represented as raster images, and we looked how to work with both of them. We saw, for example, how to merge both raster and vector layers. We saw how to clip both these types of layers using extents. For the first, we used extent we set ourselves, and another one we used extent of one of the layers we already had. And we also learned how to use raster calculator to calculate water index, for example. We also know how to polygonize raster layers, how to filter those polygonized layers, and we saw also how to use field calculators to calculate new fields with some formulas, and as well we saw how to use statistics panel to see some of the information about the layers we have. So that was it for this tutorial. I hope you enjoyed it. I hope you liked it. I hope you learned something new about, well, the QGIS itself, its functions, maybe about the region, about the topic, about the WEkEO platform and the data presented there. And yeah, you don't hesitate to repeat this tutorial yourself, following this step-by-step procedure, or maybe you can actually apply something that you learned today to some other region, to some other data you find on WEkEO platform, to some other topic, other problem or physical phenomenon. So thank you very much for your attention, and have a good one. Bye.